So this video lecture is about the size reduction. Size reduction in the pharmaceutical engineering topic. And then what is meant by size reduction? As the name indicates, reduction of the size. So this size reduction, what will be involving in the sense? It is the operation carried out for reducing the size of bigger particles into the smaller one. That to desired size and desired shape, with the shape of that only we will be doing. That too with the help of the external forces we will be doing. Size reduction is the operation that is carried out for the reducing the size of bigger particles into the smaller one. That too desired smaller shape with the help of the external forces. The another name for this size reduction, we will be calling it as a combination. And then this is the size reduction, how we will be doing. Bigger particles will be changed into the smaller particles, that to our desired shape of a smaller size. Then what are the main objectives of the size reduction? In the sense, it will increase, means by reducing the size reduction, what we can get? Means by reducing the size of the particle, we can get the surface area. We can increase the surface area, because in most of the reactions in solid particles, the rate of reaction is directly proportional to the surface area. So by reducing the size of the particles, we can increase in the surface area, hence the reaction will be happening faster. Then another thing, breaking a material into very small particles in order to separate the valuable among the two constituents. Then achieve intimate mixing, means proper mixing we can get. Why we need mixing? In the sense, while doing the formulation, we need to mix the active ingredient with the excipients and adjuvants, right? So for that, to achieve that only, we need to increase the mixing rate. Then to dispose solid waste easily. If size is reduced, it means we can easily dispose that waste, right? So to dispose solid waste easily also, this size reduction will be helpful. And then improving the improve the handling characteristics, means nothing but smaller size particles anyone can handle, right? Bigger one means only we need machines and all, right? So to increase, improve the handling characteristics. And then to mix solid particle more intimately, that only achieve intimate mixing. Then what are the advantages of that size reduction? In the sense, we can get the content uniformity. It is a content uniformity is mainly useful for the drug release, right? And then uniform flow we can get through that. And then effective in the drying, and then we can increases the surface area or viscosity of the new product. And then uniform mixing and drying also we can get through that. And then we can improve the rate of a smaller particles that is getting a absorption. We can also improve the dissolution rate of that particle. Then next one is the disadvantages. So what are the disadvantages of the size reduction? In the sense, drug degradation and contamination, means because of the new surface area it got produced, drug whatever we have reduced the size, it will easily get the degradation. And then easily, because of the new surface area which is produced, because of that itself, it will be easily getting the contamination. And then mechanisms of the size reduction. So what and all types of mechanisms it will be undergoing the size reduction? Means impact, compression, attrition, cutting. Impact in the sense, by producing the pressure on a particular sample, we can produce the impact. Means particle size we can reduce by a single rigid force. For example, you take one of the particle is hitting with the hammer. thereby it will be getting reduced size, right? Generally, in mountains and all, we will be breaking by hitting with the hammer only. Means that big rocks and all will be reduced in size to smaller ones and it will get a break, right? Like that type of mechanism only, we will be calling it as a impact mechanism. Another one is the compression. Means we need to compress, means the particle need to press between two surfaces, means crushing between the two surfaces. Like that type only, we will be calling it as a compression. Okay, so in this mode, material is crushed between rollers by the application of the pressure. That only you will be calling as a compression mechanism. And then attrition. What is meant by attrition in the sense? Any particle is a roll over each other and it is hitting with the surface of the metal. That only, otherwise another surface. That only you will be calling as a attrition. Okay, so for that you can take example as a our normal home. In a home and all, we will be using grinders, right? In that, what will be happening? There will be stone will be there and then surface will be there. There that will be rolling, that particles whatever we were going to reduce the size, it will roll over each other. By that it will get reduced size. Other than that rolling over each other of the particles, it will get to reduce the size because of due to roll over each other due to presence in the surface. So that type only you will be calling as a attrition. Okay. Then another one is the cutting. What is meant by cutting in the sense, with the sharp blades we were reducing the size of the particle. That only you will be calling it as a cutting. Okay, so these are the four mechanisms which we will be using in the size reduction. So what is that? Impact, compression, attrition, and then cutting. What is meant by impact in the sense? Particle size will get reduced by a single rigid force. That only you will be calling as a impact. And then compression. In this mode, material is crushed between the rollers by the application of the pressure. That one you will be calling as a compression force. And then attrition, arising from particles scraping against one over each other and against a rigid surface by rubbing. That type of mechanism you will be calling as a attrition. And then cutting means the material is cut by means of the sharp blade. That type of mechanism will be calling as a cutting. So these are the four mechanisms which we will be using for the size reduction process. Size reduction is nothing but the reducing the size of the particle from the larger size to the desired smaller size. So that how we will be getting in the sense, either one of these mechanisms which we will be following. Then, so as in the diagrammatic representation, the solid particle is hitting with the rigid surface. That only you will be calling as the impact. And then attrition means the particles is rolling over each other and then it is hitting with the surface. By that rolling also it is reducing the size. And then coming to this compression, this compression will be both sides. Particle will be placed between the two rigid forces and we will crush over each other. That only will be calling as a compression. Cutting in the sense of the sharp blades will be cutting. And then coming to this shear. Here the particle size will get reduced due to the shear force which is applied tangentially. Means in the tangential manner, means in the crisscross manner we will be applying the force on the particle, thereby it will reduce the size of that particle. That only you will be calling as a shear. Okay, then mechanisms and the laws which will be involving in the size reduction process. Okay, the energy requirement for a particle size reduction is a function of input and output of a particle size, hardness, strength, and other properties of the solids. Means whatever for size reduction we need some energy, right? So that for the size reduction some energy requirement will be there. That size requirement, energy requirement is a function of input. And then output, what will be there in the sense that the particle size, hardness, strength, and other properties of the solid. Means here what we will be going to do, here we will be going to do the size reduction. How we will be going to do? By following one of the mechanisms in the impact, compression, attrition, and then cutting, and then shear, right? So in all this, how we were applying? By applying some force, right? That will be that energy, right? So whatever the energy we were giving, that much size will get reduced, right? So the energy requirement for a particle size reduction is a function of input and output of a particle size, hardness, strength, and other properties of the solid. Then various for a theory, for a energy theories requirements are Rittinger's theory, Hicks theory, and Bond's theory. One by one we will see. Generally, the energy required to reduce the size of the particles is inversely proportional to the size raised to the same power. Means how much energy we have given, that much size it will get reduced. So that's what the energy required to reduce the size of particle is inversely proportional to the size raised to the some power. That one only. Differential in the energy to the differential diameter is equal to minus C divided by D power N. Here differential energy in the sense amount of energy required to produce a change in the particle size. Then the C and N is the constant. D is the size of the unit mass. Then from this equation only, another integration if we did in the sense energy is equal to constant C and ln, which is the integration of the differentiation. That ln di divided by dn. What is di in the sense? Diameter of the initial particle. And dn, what is it mean in the sense? Diameter of the new particle. So for that ratio only means initial to the final particle diameter ratio only, how much energy we have kept. Okay, that one only it will be equal to. So because of that ratio, initial diameter and final diameter ratio only, we will be getting the how much energy we have given to that particle to get the size reduced. Okay, then if n is equal to 1.0 means the new surface diameter will be 1 means it will becomes the Hicks law. Okay, then if it is n is equal to 1.5 means it will be Bond's law orbital. If n is the 2 means then we will be calling it as a Rittinger's theory. Rittinger's law we will be telling. Okay, then Rittinger's theory we will see. According to this theory, energy required means whatever the energy required for the size reduced particle of unit mass is directly proportional to the new surface area produced. Okay, so means nothing but how much energy we have given, that many new surface areas will be produced. That is that only here. How much energy we have given, that many new surface areas it will be produced. E is equal to Kr into Sn minus Si. E means energy, amount of energy which we have given, under Kr means nothing but R in the sense Rittinger's, K in the sense constant, Rittinger's constant. S is the surface area, N is the new surface area, I is the initial surface area. So how much energy we have given, how it will be, how much energy we need to give in the sense, how many new surface area we need to produce, that much energy we need to give the energy. Okay, so this was the formula. E is equal to Kr into Sn minus Si. And then coming to the Bond's theory. What is this Bond's theory in the sense? According to the energy used in the crack's propagation is proportional to the new crack produced. Okay, nothing but whatever how many new particles produced. Okay, how many new particles need to produce, that much energy we need to give. Okay, so it states the energy required for deforming a set of particle equivalent shape is proportional to the change in the particle dimensions. So E is equal to 2 into KB, the bracket of 1 by the root of dn minus 1 by root of di. What is meant by that? E means as usual energy, and then kb in this, b in the sense bonds, and k is the constant. Bonds are constant, and then d means diameter of the particle, n means new diameter, and I means initial diameter. So coming to the Fick's law. What is this Fick's law will be telling in the sense energy required to for deforming a set of particle of a equivalent shape is proportional to the change in the particle size only, it is telling. Means energy required for deforming a set of particles of equivalent shape is proportional to the change in the particle size. Means how many changes in the particle size we need, that many proportions we need to, that one proportions we need to supply the energy. Then only that required particle changes, size changes will be happening. Then here formula is the E is equal to K into K ln di by dn. K into K. K means kicks. Kicks constant. Energy. E is the energy. Kicks constant energy per unit mass. And then D is the diameter and I is the initial diameter. N is the new diameter. Then Rittinger's theory, N is equal to 2, means energy is proportional to the new surface area. Means how much energy you will be giving, that many new surface areas will be forming. Bond's theory is the 1.5, means how much energy you will be giving, that many new cracklings will be produced. And then energy will be proportional to the ratio of change in the particle dimensions also. Bond's theory only will be saying. And then coming to the Fick's theory, if n is equal to 1, means energy is proportional to the ratio of change in the size reduction. So then these are the three laws which will explain the mechanism of the size reduction. Then coming to the product, means one of the equipment used in the size reduction process, that is the hammer mill. So what is this a hammer mill in the sense? As we know, it will follows the mechanism of size reduction in the impact. Means the rigid force which will hits the particle, thereby size of the particle is getting reduced. That only you will be calling as a impact, right? So in this hammer mill, name itself it will indicates in which principle it is going to work, in the sense material is impact between rapidly moving hammers on a rotor and the powder and material. Uses, what is the uses in the sense? Will be used to mill dry materials, wet filter press cakes, and then ointments, slurries. Brittle material is best fractured by impact from blunt hammers. Fibrous materials is best reduced in size by cutting edges. And then variants, what will be the new updations in the sense? Stokes tornado mill, and then Fitzpatrick comminution mission, and then micro pulverizer hammer crusher. These are the new hammer mills versions. So what is the basic construction and working of the hammer mill? Means a hammer mill is essential and essentially a steel drum containing a vertical or horizontal rotating shaft or drum on which hammers are mounted, and then hammers will swing on the ends or fixed to the central rotor. The rotor is rotates at a high speed inside the drum while material is feed into a feed hopper, then the material is put into a hopper and then which is connected to the drum. Thereby, it will be passes one by one from the hopper to the feed and then feed to the hopper. Then finally, the metal will hits the hammer end and it will be so the particle will hit the hammer end and it will be getting reduced the size of its to the desired size because of the impact mechanism that only will be collected in the collector. So these are, and that too here, how much RPM it will be rotating in the sensor. 2500 RPM on to 1000 to 2500 RPM we will be using this. But it will be having the maximum high speed 10,000 RPM. This will work. This hammer will work at 10,000. Then advantages. What is the advantages of this hammer mill? Means it is a rapid in action and then it is capable of grinding many different types of materials. They are easy to install and operate. The operation is the continuous operation. There is little contamination of the product which metal abraded from the mill as no surface move against each other. The particle size of the material to be reduced and can be easily controlled by changing the speed of the rotor and hammer shape on the size of the screen. What are the disadvantages of this metal, this hammer mill in the sense? Heat and build-up during the heat will be produced during the process and this can be used for the sticky fibrous and hard materials because the screen which and all may get clogged. So this is about the hammer mill and then size reduction process. So here we were going to end this video lecture.